Hello everyone, welcome you all to Medical Guruji. In this video we are going to learn about pharmacodynamics and it is part 2 of the video. For the first part you can refer to the first part of the video. So in this video we start with receptor occupation theory. It is proposed by Clark and it is interaction between two molecules, drug and receptor, are governed by law of mass of action and the effect is a direct function of the drug-receptor complex. Ability to bind with receptor is affinity and ability to produce conformational changes in the receptor is intrinsic activity or efficacy. This picture shows two-state receptor model. Transducer mechanism. It is grouped into 5 categories: G-protein coupled receptor, ion channel receptors, transmembrane enzyme linked receptors, transmembrane J-state binding, and receptor regulating gene expression. This table shows characteristics of various receptor families. Characteristics of G-protein coupled receptor. Receptors which are linked to effector through one or more GTP activated protein for response effectuation. Heterotrimer alpha beta gamma subunits are there. Alpha helix, 7 spanning hydrophobic amino acid segments and 3 extracellular and 3 intracellular loops. The agonist binding site is located on the extracellular face in between helix alpha subunit. G-protein binding site on intracellular phase. Alpha subunit has GTPase activity and GDP or GTP are carriers. In active state, GDP bound to their exposed site. Active state, GDP replaced by GTP. This is CAMP pathway, adenyl cyclase. Phospholipase CIP3 and DAG pathway. Table shows major functional pathways of G-protein coupled receptor transduction. Ion channels. There are two types of ion channels, voltage gated and ligand gated. Example of voltage gated are sodium, potassium, calcium channels, and ligand gated is nicotinic and GABA receptors, etc. Agonist binding opens the channel and causes depolarization, hyperpolarization, changes in cytosolic ion composition, pentameric protein with 5 subunits and 4 membrane spanning domains, subunits arranged around the channel like rosette, NMDA receptor and GABA receptors. Transmembrane enzyme linked receptors. The most common enzyme linked receptor are epidermal growth factor, nerve growth factor and insulin. Have enzymatic activity in their intracellular portion. The enzyme is mainly tyrosine kinase. Transmembrane JK state binding receptors. Receptors regulating gene expression. The glucocorticoid penetrates the cell membrane and binds to the glucocorticoid receptor protein that resides in cytoplasm in association with Hirschsprung protein 90. GR has a steroid binding domain near carboxyl terminus and mid-region DNA binding domain. Dose response relationship, 2 component dose plasma concentration and plasma concentration response. The intensity of response increases with increase in dose, but higher dose increase in response is less marked. Potency, amount of drug needed to produce a response. Efficacy, maximal response elected by drug. More decisive factor is choice of drug. Drug selectivity. The extent of separation of drug for different effects is measure of selectivity. Salbutamol is more selective bronchodilator than isoprenoline. Drug synergism and antagonism. Synergism, when two drugs combine together produce effect greater than their individual effect. Additive effect. Combined effect of two or more drug is equal to sum of effect of individual drug. Potentiation. Supraadditive. When one drug is added to another drug, it makes the second drug more effective. Example, levodopa plus carbidopa. Antagonism. Competitive and non-competitive. Antagonist bind with the same receptor as agonist in competitive and bind to another site of receptor in non-competitive. Antagonist resembles chemically with the agonist in competitive and does not resemble in non-competitive. Parallel rightward shift of agonist in competitive and flattening of agonist in non-competitive. The same maximal response can be attained by increasing dose of agonist in competitive and maximal response is suppressed. Intensity of response depends on the concentration of both agonist and antagonist in competitive and maximal response depends only on the concentration is non-competitive. This figure shows drug response curves showing competitive and non-competitive. For more, keep watching Medical Guruji, share and subscribe our channel. Thank you.